everybody, this is a quick video in case you need some help on the March 31st, Tuesday, March 31st review assignment. Numbers 1 through 6, this is ironic, numbers 1 through 6 come mostly from section 1.6, okay? So a very quick review. When you're multiplying like bases, like 7 and 7, same base, 5 and 5, x and y and y, if you're multiplying like bases, and those and obviously since we call them bases, they're going to have exponents, okay? So the shortcut to do that is to add the exponents. So there's no examples exactly like this on the assignment, but 7 to the 3rd times 7 to the 10th, that would just be 7 to the 13th, because you would add the powers. This problem right here, x, which technically has a power of 1, x times x to the 13th, since that power is 1, it's going to end up being x to the 14th when you add those powers. Here we can we can't actually multiply these together per se, because they're not the same base, but you can do x to the 3rd times x to the 2nd, and you can simplify there. And when you put x to the 3rd times x to the 2nd, that'll become x to the 5th. And then y to the 8th times y to the 10th, that'll be y to the 18th. Okay. Now let's say we had some numbers involved as well out in front. So it was like 5x to the 3rd y to the 8th times 2x to the 2nd y to the 10th. 5 times 2, that's just typical regular 5 times 2 that you learned back in like 2nd grade or whatever, okay? So these are not bases with powers, where this is just a regular 5 times 2, so that'll be just 10. And so if this was your problem, your final answer would be 10 x to the 5th y to the 18th. Now the other review topic or teaching point, right, is when you are dividing common bases, like 5 to the 7th divided by 5 to the 3rd, or x to the 3rd divided by x to the 7th, and whatever. The shortcut there is to subtract the powers, okay? So this right here, for example, your final answer, you could say, is 6 to the 2nd power, which is just 36, but 6 to the 2nd power because we subtracted the powers. Here, remember, there's technically a power of 1, so this final answer would be x to the 12th, because 13 minus 1 is 12. Here, like I said, you would just simplify the x's and the y's separately. So this answer would be x to the negative 4th power, y to the 5th. Okay, x to the negative 4th times y to the positive 5th power. Okay, and if there happen to be normal numbers that were coefficients involved, then those would just divide normally. Okay, 6 divided by 2 is just 3. Okay, so it's important not to confuse the fact that we are dividing with the shortcut of subtracting the powers. Okay, you're subtracting the powers. So in other words, when you do y to the 15th divided by y to the 10th, you are dividing this whole y to the 15th divided by the whole y to the 10th, but the shortcut is to subtract the powers and get y to the 5th. but the 6 and the 2, those are just normal numbers. And you just straight up do 6 divided by 2, which is 3. So you would get 3x to the negative 4th, y to the 5th. Alright? Now if these were switched, and it was like 2 divided by 6, well, that's not clean division, okay, but you can at least reduce that fraction to 1/3. So you could say 1/3 x to the negative 4, y to the 5th. If you had something different like 5 over 6, 5 divided by 6, well, that's not clean division, nor can you reduce that as a fraction, so you couldn't really do anything. You would leave it as 5/6 times x to the negative 4, y to the 5th. Now, on a side note, okay, negative exponents are not really good for final answers, but we're not going to cross that bridge here, okay? Numbers 7, 8, and 9, remember that when you have variables on both sides, you have to move them to only one side. So, for example, in this, you would move the 2x to the other side by subtracting it. So how do you make the 2x disappear from the right side? You would subtract it. So when you subtract 2x, now it's gone and it's not on the right side anymore, but whatever you do to the right side or whatever you do to one side, you have to do to the other. So here we subtract 2x from both sides, so it becomes 3x minus 2 equals 1, because there's no more x on this side anymore. And now you would continue like normal. You would add 2 to both sides, because now from this point on you want to get x all by itself. Once x is only on one side of the equation, on one side of the equal sign, you want to get x all by itself. So we have to cancel out this negative 2 from this side. So we would add 2 to both sides, and we would get 3x equals 3. And then we would now get rid of the 3. We would want to undo the 3 to leave x completely by itself, and you would divide both sides by 3, because this says 3 times x, and the opposite of multiplying by 3 is dividing by 3. So you would divide both sides by 3 and get a final answer of x equals 1. Alright, a couple more quick examples right here, and if you caught this for a second, a pretty good tip is to move the smaller one, when you're thinking okay, should I move the 5x to the other side or away from this side, or should I move the 6x away from that side? You can move the smaller one. So 5x is smaller, so if we were to move this away from the right side, we would subtract 5x from both sides as a start, okay? Here, if you were following that strategy, the 3x is smaller when you compared the 3x and the 5x. So you would move the 3x away from the left side, and you would subtract 3x. So pardon this is just using my mouse, so it's ugly. But that would leave 7 as the only thing on the left, and then 5x minus 3x, that becomes 2x, and we still have a minus 21. See, now we want to get x by itself, I guess, on the right side. We start by getting rid of the minus 21, getting the minus 21 away from x. So doing the opposite is adding 21 to both sides, and so that makes it a 28 over here, and that leaves 2x over here. And now to finish getting x by itself, we want to cancel out the 2, so it's 2 times x, so the opposite is dividing both sides by 2, and we get 14 as a final answer. 14 equals x. Alright, and the last thing on the review assignment is number 10 and number 11. And you just got to remember that you can treat this stuff in scientific notation, the same way you would treat exponents. So if you have an example like this, 5 times 10 to this power times 1 times 10 to this other power, you can do the 5 times the 1. Those are just normal numbers. 5 times 1, that's just, well, yeah, here's a little, this is kind of what I'm saying. 5 times 1 is just 5, and then 10 to that power times 10 to this other power, you can add the powers. And so you could say this is your final answer, especially if the directions are telling you that your final answer should be in scientific notation. Like, I know 5 times 10 to the 15th is some number, it's some giant number, okay? But the directions are saying leave your answer in scientific notation. And then if you were dividing, whether it's written like this with the division symbol or whether it was written as a fraction, it's still division, okay? And so you could literally do 3 divided by 1, because those are just normal numbers. So you're written as a fraction, you could do 3 divided by 1, and you could do 10 to the 20th divided by 10 to the 6th by subtracting the powers. Okay?